Chapter 9, Coordination Compounds. The name suggests that there is a coordinate bond between the atoms in coordination compounds. First of all, what is the coordinate bond or coordinate bonding? Coordinate bond in which one of the atom donates a lone pair of electron to the electron deficient atom, and this lone pair is shared by both the atoms. That bond is called coordinate bond. For example, is a simple example like in case of ammonia. These are three hydrogen atoms which are covalently bonded with the nitrogen, and this is one lone pair. When a electron deficient atom or ion like H positive it has one empty orbital, and this is the lone pair of nitrogen, and this lone pair is donated by nitrogen to the H positive, means electron deficient ion, and this lone pair is shared by both the atoms nitrogen as well as hydrogen, and this forms the coordinate bond, which is represented by an arrow. This arrow represents the coordinate bond, and this type of bond exists between the atoms of coordination compounds. The next question is, what are coordination compounds? Coordination compounds are those compounds in which the central metal atom is linked to a number of ions or neutral molecules by coordinate bonds. These type of bonds are called coordinate bonds. It means the central atom, metal atom, is linked by the number of ions or neutral species by coordinate bonds. For example, in case of tetracarbonyl nickel, this is tetracarbonyl nickel, in which nickel is the metal atom which is linked to the, here nickel is the central metal atom and CO is the neutral molecule. Which is linked by coordinate bonds. Here CO is linked to nickel by the coordinate bond, and this forms the coordination compounds having formula NiCO4. Another example of this type of compound is FeCO5, in which 5 CO carbonyl groups, neutral molecules, linked to Fe central atom by the coordinate bonds. Why we study the coordination compounds? What is the purpose of studying the coordination compounds? The coordination compounds are used as a catalyst in industries to alter the rates of the reaction, and these are also used in the biological processes. For example, chlorophyll, a green color pigment, is a coordination compound of magnesium. Chlorophyll is a coordination compound of magnesium. And another example is hemoglobin. Hemoglobin is also a coordination complex of iron. Hemoglobin is a coordination complex of iron. Similarly, vitamin B12, in which cobalt forms coordination complex. Next is the complex ion. Complex ion is the species which is formed by linking the number of ions or molecules by coordinate bonds to a central metal atom. Here, in case of hemoglobin, iron is the central metal atom. In vitamin B12, cobalt is the central metal atom. In chlorophyll, magnesium is the central metal atom. Or ion carries positive or negative charge. For example, in case of FeCN6 4 negative, AgCN2 negative. Here, Fe is the central metal atom and Cn is the ligands. Cn is the ions, negative ions which are linked to the Fe, central metal atom. And this whole compound carries 4 negative charge. And that's why it is called as complex ion. And in case of AgCN2, it carries 1 negative charge. Here it is 1 negative. That's why it is called as complex ion. The branch of inorganic chemistry which deals with the study of coordination compounds is known as coordination chemistry. Coordination chemistry. Next is types of complexes. There are 3 types of complexes. First one is cationic complex, in which the complex ion, this is the complex ion, which carries a net positive charge. Here it carries +3 charge. CO is the cobalt, that is central metal atom. NH3 is the neutral molecule which is linked to the cobalt by coordinate bonds, and here the whole complex carries +3 charge. Due to this +3 charge, it is called as cationic complex. Next one is the anionic complex. In anionic complex, the complex ion carries a negative charge, net negative charge. For example, in case of FeCN 4 negative, AgCN 2 negative, etc. Here Fe is the central metal atom, Cn is the negative ion, and it carries 4 negative charge. Due to this 4 negative charge, it is called as anionic complex. And third one is neutral complex, in which there is no net charge is present on the complex. For example, NiCO4, tetracarbonyl nickel, and pentacarbonyl iron. Here 5 carbonyl groups are coordinated with the iron, and in nickel carbonyl 4 carbonyl groups form coordinate bonds with the nickel, where CO is the neutral molecule which is coordinated to the central metal atom. And these are 3 types of complexes: cationic, anionic, and neutral complex, depending upon the charge on the complex ion. Next topic is double salt. You have heard about the potash alum, commonly called as fitgri, which is used for the purification of water. And the formula of this potash alum is, which is used in the daily life, K2SO4 Al2SO4 thrice 24 H2O. This is the formula of potash alum. As you can see here, there are 2 salts in potash alum and 24 water molecules of crystallization. It means in double salts, 2 or more stable compounds combined in a equimolar proportions, equimolar ratio. Double salts are formed by combination of 2 or more stable compounds. These are stable compounds in equimolar proportion, in equal ratio. And the next example of double salt is Mohr's salt, which we will use in the volumetric analysis. Volumetric analysis, in which Mohr salt is treated with the KMnO4 solution to determine the normality or molarity of the Mohr salt by knowing the molarity or normality of the KMnO4 solution. This is the formula of Mohr salt. It also have 2 simple salts, 2 simple stable compounds, FeSO4 and ammonium sulfate, NH4,2SO4, and 6 water molecules of crystallization. Double salts always exist in solid state, and in aqueous solution they dissociate completely into ions. Means there is 100% dissociation of compounds into ions. And in double salt, the metal ions like Fe, this is the metal ion, it shows the normal valency. Here in case of FeSO4, its valency is +2. And the double salts loses its identity in the solution because they dissociate completely into its ions in aqueous solution. That's why they loses their identity. Now some important terms which are used in coordination compounds. First term is the ligands. Ligands are the donor atoms or molecules or anions which donate the lone pair of electrons or pair of electrons to the central metal atom or ion and forms a coordinate bond. For example, H2O, Cn negative, NH3, etc. These are the ligands and they donate the lone pair of electrons to the central metal atom, and that's why these are called as donor atoms or Lewis bases. Donor atoms are called as Lewis bases because they have tendency to donate a lone pair of electrons to the other atom. Next is the central metal atom or ion. It is a metal atom or ion to which these ligands are attached. For example, in case of CONH3 6 3 positive, CO is the central metal atom and NH3 is the ligand. It is a neutral ligand and the lone pair of electrons on the nitrogen is donated to the cobalt. That's why it acts as a Lewis base. And CO has a tendency, cobalt metal atom has a tendency to accept electron, and this central metal atom is called as acceptor or Lewis acid, because Lewis acids have a tendency to accept a lone pair, a pair of electrons, and in this case this central metal atom have a tendency to accept a lone pair of electrons from the nitrogen of NH3, which is a ligand or Lewis base, and the coordination compounds are the products of Lewis acids and base.